the first time you open Matlab, the interface is going to look more or less like this. So this is a version that's 2014A, so R 2014A. It's not the newest version, but the interface should for some recent versions of Matlab, the default interface should look more or less like that. So at the top you have several tabs. One is called Home, and then Plots, Apps, and then on the underneath the menu bar you have several windows. One of the windows shows the current folder. It's showing you the content of the current folder basically. So, and then you have a command window, and then you have a workspace window. So the command window is some place that you can type commands that Matlab are gonna recognize and then respond to. And if you have error messages, it's also gonna be displayed in the command window. We're gonna type commands inside of this command window shortly. And then you have a workspace, which basically displays all the variables, their name, their type, and then their sort of size inside of your memory, inside of the memory of your working Matlab. So you have these three most basic windows. And then between the menu bar and the three biggest windows, you have this row. First, you have some icons here, back and forth. So it allows you to go back and forth to your current and previous locations in the file system, basically. And then go up one level. So if I click on this button, you can see that the stuff that's inside of the current folder actually has changed. So it's actually changed to the folder that contains my previous folder, which is my home directory, Pochen actually. So if you want to go back to the previous folder, what you can do is to click the back arrow, and then it's going to take you back to the previous location in your file system. And if you want to go forward, click on this. So these two arrows basically allows you to navigate back and forth in a file system. And this icon allows you to go up one level. So this is up one level up in your file system. And then click again another level up. And if you want to go back, like do things like that. And so this icon, if you hover your cursor over any of the icon, it's going to tell you what this icon is for. So this one is for browse for folder. So if you click on it, it's going to open this dialog box, and then you can sort of select a new folder or something. And then for example, if I want to look into my work directory, then you can sort of go there, or you can click on either double click or just click on open. So if I want to open this particular directory, I'll click on open. Then it's going to switch to that particular directory that you just selected in that dialog box. So if you want to go back, click on this arrow. And then you have this thing. It's basically displaying your absolute path in your whole file system. It's displaying the whole path, the complete absolute path of your current folder inside of your entire file system. And if you move your cursor over this line, you can sort of see some of them are actually clickable. So you can click on it. It's going to display the folders in the home directory, for example. So slash actually represents a home directory. So if you click on slash, it's going to take you direct to the home directory. And then if you click on this triangle, it's going to list all the directories under the under the root directory. It's the root directory. The slash represents the root directory, not home directory, root directory. And then the folder that you are currently sort of in is sort of highlighted in bold. So you are currently inside of the home directory underneath the root. And then if you click on this arrow again, it's displaying all the directories inside of home. And then the current active directory is highlighted in bold. Again, it works pretty much the same way. So it's actually telling you the path, the absolute path of your current working directory. So let's type a few commands. Suppose I want to find out my current present working directory. I can use a command that's called pwd. And then it's telling me my current working directory is /home/pochen. That's my home directory. And then you also see there's a variable that's called ans. This is sort of the default variable. So if you type a MATLAB command, and then the result of that command is going to be stored temporarily inside of this ans, this temporary variable. And inside the workplace, you're going to see you have one variable now. It's called ans, and then it has a value. It's basically a character string, home pochen. So that's sort of the workspace, what this workspace is for. It's for displaying the variables that's currently in your MATLAB workspace. So if I want to list all the current directories, all the current folders and directories, files that's inside of my current directory, I can do ls. I can type ls. Then it's gonna give me a list of the files and the directories in my current working folder. And this time you don't really see an ans because the output of the ls command is not really stored in a particular temporary variable. And if you actually try to sort of switch directory in the command line, suppose I want to go to my Dropbox folder, you can use the command called cd Dropbox. If you don't want to type all the letters, you can just use tab. Use the tab key to complete the file name. And now you can sort of see it's I have switched to the Dropbox folder, and then everything is everything inside of my current folder has changed to that particular folder. At this point, if you type pwd again, it's going to tell you your current directory is home pochen Dropbox, and the value inside of the ans has changed. It has changed, and you can sort of see how it's actually changed to a different value. And so now let's look at some of the buttons. That's kind of important. So you have different tabs. For now, you have 3 different tabs: home, plots, and apps. And then you have some shortcut buttons that's located here. So some of the buttons, some of the icons are grayed out for now because they are not active for now, because you don't really. For example, this is actually a save button. You can see it's a disk cut, paste, cut, copy, paste, undo, and redo. So undo and redo. And then switch windows. If you click on switch windows, it's going to give you a drop-down menu that's going to display all the possible windows that you can look at. So I have a command window now, which is active, which is this window. I have a command history window. This window is not really active for now, but if you click on it, it's going to display a window that contains all the commands that I have typed previously, up to a certain storage limit. So that limit also can be sort of configured if you want to sort of keep track of all your longer histories. Then you can sort of try to configure that. That's called command. If you want to look at that window, you can sort of go here and then just choose command history. Current folder window, it's active. Workspace window, that's active. Right. So these 2 buttons are quite useful. The undo button, it's also actually showing you the keyboard shortcut, Control Shift minus, and this is redo, Control Shift Z. So this shortcut actually means that you have to hold down the Control and Shift key, hold down these 2 keys without releasing them, and then type the minus key. So that's sort of the meaning of the key combination. Copy and paste. So this is on a Linux operating system, so copy. And in this kind of system, MATLAB has a different kind of key combination from if you are a Windows user. On Windows machines or on a PC, you probably use Control C, Control V to copy and paste the stuff. On this Linux machine, it's using a different convention, different key combination actually. Alt W copy, and Control Y for paste, and then cut is Control. It's Control W, save button, and then new shortcut. So you can actually configure this shortcut bar by yourself to add new shortcut buttons here, and you can also sort of write your own sort of comments or tips, tips or key combinations, that kind of thing, to explain what this icon is for. You can sort of configure this shortcut bar by yourself. So inside for this home tab, you have some quite important buttons. Um, for, so suppose you would like to write a Matlab script. You can use either this button, it's called a new script, or this button. This button has a triangle. If you click on it, it's going to give you a bunch of options. If you want to write a script, a function, example class, system object, that kind of thing. And because Matlab is actually an object-oriented language, so you can write object language, use classes in Matlab scripts, functions or something. And this button is basically for you to open particular files. And if you click on this arrow, this triangle, it's going to show you some recent files that you have been editing. I have been editing. Sorry. Find files, compare files, import data. Suppose if you have a Excel spreadsheet data you want to import into Matlab and do some data processing on that spreadsheet data, you can use this button to import that data into your Matlab workspace. Save workspace, it's going to dump everything, every variable that's inside of your current workspace into a big binary file. And next time if you want to sort of reload everything that was in your workspace, you can just load that particular file, that particular workspace file, and then your environment is going to go back. Your variables is going to go. All your variables are going to be sort of recovered to your previous state. New variables, open variables. These are for you sort of to examine variables. Clear workspace. If I click on this button, all variables will be deleted. Do not show this prompt again. I'll say OK. So now workspace is like empty. There's nothing in it. And then you can click on this triangle, and then it's going to allow you to select the variables you want or functions or breakpoints that you want to sort of clear from your current workspace. Analyze code, running and time. These are for some if you are writing functions or writing scripts, these will be very useful. Simulink library. Simulink is another big chunk of a big component of Matlab actually. So we won't have time to talk about Simulink in this particular video, but maybe in the future we can talk about it in more detail. Layout. So if you click on this triangle, it's going to show you different kinds of layout. A layout is pretty much just a specific choice of the windows that you are trying to display at the same time. So by default, the default, it's gonna, if you click on default, it's gonna give you this kind of window, this kind of layout, exactly the same as what I was showing you before. But you can also choose different kinds of layout. For example, 2 columns. If you choose this kind of 2-column format or layout, the interface is gonna look like that. You have command window, workspace down there, and then you have a current folder. This is sort of a layout that's kind of compatible with previous versions of Matlab. If you actually go back to 2010 or 2009 versions, 2007 versions, the interface looks, the layout of the windows looks pretty much like that. Then all but command windows minimized, that kind of thing. So this is sort of pretty much based on your own preference. You can choose whatever you want. Save layout. If you like a particular layout, you can sort of save it. Command history. What I was showing you is that the command history window, for now it's sort of a pop-up window. But if you want it to be docked, you can also choose it to be docked. Then now, so command history is like a docked window. It's not like a floating window that's hanging around. Preferences, where you can configure your sort of preferences. SetPath. So SetPath allows you to sort of load some script at the startup of your Matlab. It also allows you to set the path that the Matlab can sort of automatically look for scripts and functions. So SetPath. So for now it's actually sort of having some kind of default values. So it's gonna look into my home directories or the toolbox that I've installed on my MATLAB sort of system. So it's gonna look into this, it's gonna look into all these folders or paths to look for scripts and functions. So in the command, if I type some command, suppose I type ls, no, this is actually a system command. Suppose I do a help, I type the help command. Then it's gonna call some particular MATLAB function or MATLAB utility that's gonna display this kind of information for me. And where it's gonna find this particular help command, it's gonna find the help command in those paths or directories that's already specified in the SetPath window that I have sort of looked at. So you can if you have a particular directory that contains all the scripts that you have written, and you would like to automatically load load that particular path into your search path, you can sort of set up that you can sort of add your own path inside of this window. For example, if you want to add folder, then it's going to ask me to add a particular folder. Suppose I would like to add some folder. Suppose I want to add tools, scripts. Do I have this folder? No. I have to go up one level. Tools, then scripts. So suppose I would like to add this particular folder into my search path. I can do that. Now. I have home PoachN tools scripts that's automatically loaded into my MATLAB search path. So it's gonna look for scripts, MATLAB scripts inside of this path in addition to all the paths that's already in there. So that's how you can. So it's if you close this window, it's gonna ask you if you want to save your current path for future use. I'm gonna say yes. Oh, so it's actually telling me my path def.m cannot be is read only. I cannot write to it. But anyway, you can sort of the reason that the reason that I cannot write that I cannot sort of do that is because that path def file is a system-wide file. But what you can do is that you can go back to the command line using a command that's called add path. And now the path is going to be added to your MATLAB search path directory. So add path, using add path to add a particular path, a search path to your MATLAB search path using a command line. So that's set path. Parallel, if you are developing parallel programs, this button is useful, right? And these buttons are sort of for you to actually request for help, to support. And you can also use this. So suppose I want to search for all the information that's related to add path. Then it's gonna display this window. It's gonna show me all the information that's related to this add path command. So you can sort of use this search bar to look for information about particular commands. So suppose I want to find all the commands that's kind of related to sort of filtering. I can use a command that's called look for filter. Then it's going to search through all the MATLAB documents and find all the commands or utilities that's kind of related to filtering. And you can sort of see there are lots of them. And it's actually just displaying all the commands that has filter that's inside of its documentation. Or so basically you have three ways for you to actually look for help. Type in the search document window. Use a command that's called look for, followed by any kind of keyword that you're actually trying to sort of find information for. And then there's a third command that's called help. So if you know the name of the particular command or function that you are actually looking for, you can use help. Suppose I want to find the help page of look for. I can just help look for, help followed by the name of the command. And then it's going to display the information about how to use the look for command. So if I do help, then it's going to display how to use the help command inside of the Matlab. So Matlab is actually a very good self-documenting system. So every time that you have a question, you can ask Matlab and try to find some help. And of course, you can also Google. You can Google for a specific question. And the internet has a tremendous amount of resources um, for learning Matlab actually. So this is the home tab, and then you also have a plot tab. For now, we don't really have any data to plot. So all those icons, all those buttons are grayed out. So you cannot really make any plots. And we're going to look at those buttons later on. But all those buttons actually correspond to specific commands. And you can sort of see the name of those commands down there. So plot, bar, area, pie, hist, contour, all those are actually Matlab commands. And those buttons just is a encapsulation of those commands. So by clicking on that particular button, it's equivalent to typing those commands, typing those function calls inside of your command window. It's actually equivalent. And these are specific functions for making plots. And then if you click on the apps tab, these are specific functions for specific purposes, not exactly for plotting. For example, curve fitting. If you have a bunch of observation points and you want to fit a curve through those points and try to minimize the kind of discrepancy between the curve and all the observations, you can use this particular toolbox. So this is like a small toolbox. It's called apps. It's just like a small module or small function that I can use to adjust, for example, the parameters of the curve, that kind of thing. Optimization is another kind of toolbox, but it's sort of encapsulated with some kind of graphic user interface. If suppose I click on curve fitting, it's actually giving you this kind of graphic user interface, so you can work with, you can work by clicking those buttons instead of typing commands in the command window. For now, I don't really have any data in the memory space, so it looks empty. Of course, if you want to install more apps, you can use this button. If you want to sort of package your own apps, you can use this button. Get more apps, download apps. You have some more apps. All those different apps have different kind of utilities. It's basically a graphic user interface for some specific toolboxes inside of the Matlab. So the number of buttons that's going to be sort of available to you depends upon the number of toolboxes that you have installed. If you are using a student version of the Matlab, you probably don't have this many buttons. That's just because some of the toolboxes are not installed for your version of the Matlab install. And here it's just some of the most commonly used apps. But if you click on this triangle, it's going to display all the available apps that's available for this particular installation. So that's the 3 tabs. That's basically 3 tabs. Let me go back to the home button. Suppose I want to write a new script. I click on this button. Now you can sort of see I have one more window here. That's called editor. Of course, you can drag your editor over to make it bigger. So all those windows can be sort of dragged around. You can reconfigure the layout by yourself. So if you want to have a bigger editor window, you can just sort of make the window bigger. But now you can sort of see there are 3 more tabs here. One is called editor. The other one called publish and view. So if you write a Matlab script or Matlab function or whatever whatever text file that you have to sort of edit, you're gonna get this editor tab. This tab basically groups together all the buttons that can be used when you try to write a script or functions. And some of the important things, if you want to debug your codes, You can set breakpoints using this button. And once you actually started to debug codes, this run button, run and advanced button allows you to navigate through your code and discover where the problems are. Run sections. So if you want to organize your codes into different sections, you can do that and then just run a particular section and leave out every other sections. And if you are done with your script, you decide to give this script as some kind of publish this script as some kind of for example, report, you can use the publish tab. It allows you to convert your script into some sort of more dynamic document format. For example, it allows you to use LaTeX. It allows you to publish as a website or web page or as a PDF file, as a Word document. You can sort of select those different kinds of sort of formats for exporting your script or functions. And then view allows you to sort of different ways for viewing text files. So basically that's a very short tutorial about the interface, the Matlab interface, and how you can actually use it to work with your sort of to process your data, that kind of thing. Now let's look at how we can actually use the command window to use. We can basically use Matlab as some kind of glorified calculator. It allows you to do calculations. Suppose I want to sort of do some kind of mathematical formula. So I'm going to do some SQRT. SQRT is basically for taking the square root of something, and it's a particular Matlab function. And to call a particular Matlab function, you have to use a name, and then give it some kind of input. Let's give it like 5, and then subtract 1, for example. So it's basically 3 times the square root of 5 subtract 1, and then divide. Let's make it slightly more complicated. 5 plus 1. So divided by the square root of 5 plus 1. So you have to sort of use the parentheses to group together the commands, to group together a certain expression in order to sort of precedence, because the divide has a higher precedence than subtract or plus. So if you want to sort of compute this thing first, you have to use the parentheses to group the commands together. And then let's maybe raise the power by 2. So I'm taking the square root of 5 plus 1 and then raising the whole thing by 2, by a power of 2, and then subtract 1, for example. So it's telling me P has a value of minus 0.6559. Basically, it allows you to sort of use it as a calculator, basically. So you can also do this same kind of thing on a calculator, but inside of the Matlab, you can just it gives you a bigger window, so you can sort of look at things more easily. And it also has lots of built-in functions. SQRT is just one of the built-in functions for taking the square root. Let's look at Q1 equals to, now let's take a log, exp3. So here I'm looking at the two functions, exp, the exponential of 3, and then log. Log actually means the natural log. So here I'm supposed to get a number 3 back. So this is actually a natural log. If you want to use the 10 based log, if you do Q2 log 10 exp3, now this is a 10 based log. So log 10 is actually the 10 based log, and it's actually giving you a different value from Q1. So let's look at some trigonometry functions. So R equals to sine pi divided by 6. So pi is actually a Matlab built-in variable. It's just it's 3.14 those sequence of numbers. That's the pi. So you can just use that particular number pi by just typing the letter pi. So here I'm calling the sine function here, and then again raise it by power of 2, for example. Cosine. I'm going to use parentheses. Pi divided by 3, and then raise power by 2, telling me it's 0.5. And then it also allows you to use complex numbers. So how do you actually use a complex number? 1 plus the letter I. If you actually follow a number with the letter I, it's going to treat I as the imaginary unit. So 1 plus 3i is actually a complex number. And 1 is sort of the real part, and 3 is sort of the imaginary part. And then you can sort of divide it. So it actually supports all the arithmetics on complex numbers. You can just do that. And then it's going to give you the the result, which is also a complex number with the real part that's minus 0.8, and then imaginary part that's 0.6. And basically that's some of the arithmetic functions. So star means multiply, subtract, plus, log 10, exp, sine, cosine, complex numbers, all those trigonometry functions that you can think of. It's sort of built into Matlab. And then complex numbers is kind of important once we start doing the Fourier transform, that kind of thing. And there's also a few round-off functions. So suppose I have here I'm going to define a new function, new variable, but this time I'm going to define a vector with just 2 elements, minus 2.33, space 2.66. So here you can sort of see how I actually write a vector. The name of the vector followed by equal to is basically assignment operator. You assign this particular thing to A, and this particular thing is called a matrix notation. So square bracket is used for denoting the stuff that's called a matrix. And for this particular example, it's basically it has just one row. So it's essentially a vector. It has just one row, right? So as soon as you type in this command, it's going to display a new variable here. So it has a name, and then a value, name and value, right? So let's look at a few round-off functions. So fix A. Fix A is going to sort of round it towards 0. Round the number towards 0. So minus 2.33, it's going to round towards 0. That's minus 2. Towards 0, that's 2. So that's called fix. And then let's look at another function that's called floor. So floor is going to round towards minus infinity. So towards minus infinity, that's let's give you minus 3. And then floor of the positive number is just taking the integer part of that number. And then CO is gonna round towards positive infinity. And then you also have another function that's called round, of course. That's towards the nearest integer. And you also have another function called the remainder. Suppose you do a division. And then you want to get the remainder of the division. So suppose I define 2 vectors for now. 4, 9, 11. That's A. And then I define another vector. 2, 4, 3. That's another vector. So if I want to get the remainder of this division, element-wise division, 4 divided by 2, 9 divided by 4, 11 divided by 3, I can use REM function, A and B. And then it's going to give me the remainder. So 4 divided by 2, the remainder is 0. 9 divided by 4, the remainder is 1. 11 divided by 3, the remainder is 2. So REM is also a quite useful function. So now let's try out those functions. So suppose I have 2 variables, p equals to minus 0.6459, and then q2 equals to 1.3029. And then let's try to use the fix function on p plus the floor function on q2. And let's see what's gonna it's gonna give me 1. Let's see why it's 1. If I do fix p, it's gonna round towards 0. It's minus 0.6 something, round towards 0. It's gonna give me 0. And then floor q2, it's rounding towards minus infinity. Then it's 1. Q2 is 1.3 something, round towards minus infinity, it's 1. So 1 plus 0 is gonna give me 1. So seal, let's do seal q2 plus round p, still 1. So seal q2 is 1. Seal q2 is 2. That's rounding towards a positive infinity. So q2 is 1.3 something, so it's 2. And then round p. P is what? P is minus 0.6, rounding towards the nearest integer. So it's actually giving you minus 1. So the nearest integer for p2 is actually for p is actually minus 1. So that's how you can actually use those rounding functions. You can also define your own functions. You can define actually your own inline functions, for example. Suppose you have some kind of a expression. So suppose you want to compute the function x squared multiplied by y, multiply y. So what you want to do is to define a function that's called fxy equals to x squared times y. You want to define something like that. So how do you actually define a function inside of Matlab? You can of course write a function script, write a function text file. But if your function is really short, you can use the inline. You can use the inline keyword or inline sort of inline command provided by Matlab, and then just put the expression inside of the single quote sign. So fxy equals to inline, and then x squared times y, and then the expression has to be sort of inside of a single quotation period. And now it's actually telling you fxy is the inline function. So now suppose I want to use x equals to 1, assign 1 to x, and then assign 2 to y. And then if I want to call fxy, then it's going to give me 2. 1 taking the square is 1 times y, 2, right? So you can use a inline function. So suppose you want to give it some sort of arbitrary value, so sort of pi, suppose I give it pi, and then 2.3, for example. So pi is what I was telling you is a built-in number. So it's a pi squared times 2.3. So pi squared is what? Pi squared is 9.686 something times 2.3. So it's exactly the same. So you can use inline function to define some very short functions or very short expressions, and then you can just use that function just like an ordinary or built-in MATLAB function. Here you're actually using it with 2 variables as input, and those 2 variables have specific values in it. So it's kind of equivalent to calling fxy 1, 2. But instead of putting the numbers 1 and 2 into it, I'm actually using the variables x and y. And if you actually change the variables inside of x and y, you have to sort of call this command again to reevaluate the result. And here I'm just putting 2 numbers into it. So that's called inline functions. Now suppose we want to do some sort of slightly more complicated formula. So I'm going to do fxy equals to inline x to the 5th power plus y squared divided by exp, exponential x divided by y. And then that's going to be my formula. So it's basically x to the 5th power plus y to the 2nd power. And then that's the sort of the denominator. And then denominator is e to the x over y's power. So so it's an exponential function, x divided by y. It's slightly more complicated, but essentially it's still the same. So you can still call it fxy, and then give it like a 5 3 5 3, right? Minus 4 2. So you can just use those inline functions just like an ordinary built-in functions, and put some sort of input into it. Um, so Matlab is actually a short name for matrix laboratory. So its real strength is in terms of its capability for dealing with matrix and vectors, for dealing with the linear algebra operations. So the basic data type or the basic data structure in Matlab is called a matrix. So how do you actually construct a matrix, right? Last time I was showing you how to construct a matrix with just one row, which is basically a vector. But you can also try to write an ordinary matrix like that. 16, 3, 2, 13. So the elements on the same row can be separated using space or comma. Here I'm using space. And then the different row can be separated using a semicolon. So 5, 10, 11, 8. Here I'm all using just the integers, but internally MATLAB are going to treat them as double precision floating point numbers. 9, 6, 7, 12, 4, 15, 14, 1. So this is going to give me a matrix. So the different columns on the same row are separated by space, and then different rows are separated using semicolon. So that's how you can actually type in a matrix, basically. And let's try a few more. Let's do another matrix that's called K. That's the first row, right? And then that's the second row. And then 5, 2, minus 1, 3. Third row. I'm gonna just do like a 3 row, 4 columns. And then let's try to do something that's has different shape. 3, 4. That's gonna be the first row. 1, minus 2, second row. 6, 5, third row. 3, 2. So it's a 4 row, 2 column, right? And so suppose you would like to sort of you would like to store the matrix inside of a text file. So what I can do is that one of the ways for doing that is to write a script. Suppose I want to write a new script. I'm gonna click on new script button, and then it's gonna open the editor. In your case, the editor window could be opened in a different position, but you can always drag it to whatever position that you like. So suppose I want to use this A matrix quite often, but I don't want to type it every time that I'm gonna I'm every time in the command window. So I can put it into a script, for example. So here I basically selected it, right click on the selection, and then select copy. And then inside the editor window, you can just right click and then paste. And then give the semicolon to suppress the output. If you want to save it, you can save it. Click on the save button. Let's just call it script1.m. I'm going to save it under some kind of a temp directory. So here it's actually giving me the current working directory. But I don't want to sort of save it on my home directory. I want to save it in some specific subdirectory. It's called temp. I can double click on it, and then if I save, then script1 is going to go into here. It's actually displaying the completed file name, home poaching temp script1.m. So now in my workspace, I have a variable that's called a. It's telling me it's a 4x4 double. So here it's actually displaying the size. It's 4 row, 4 column, and the type for each of the element inside of the A matrix is a double. So if you want to clear out your memory space, I can do clear. If I type clear, then it's gonna delete all the variables in my memory. If I want to delete a specific variable, so I want to delete a, big A, I can type clear A. And now you can sort of see big A has disappeared. If I type clear, now everything has disappeared in my workspace. But if I run this particular script, you can run it by clicking on this run button. Or inside of this, for now you are in the home PoChain directory, right? So if you actually type script1, it's telling you undefined function or variable called script1. The reason is that this temp directory is not added to the default search path of Matlab. So if you actually do a cd temp, if you switch to the temp directory and do an ls script 1.m, now you can sort of see script 1.m. And this temp directory is becoming the current working directory, the present working directory. And now if you type script 1, then it's going to run. And now you have the A variable, A matrix that's 4x4 double. And if you want to look at its content, it's right there. The reason that it's not displaying, the script is not displaying A by default, is because of this semicolon. If I get rid of this semicolon, save it, and then click on the run button, you can sort of see it's actually, every time it runs the script, it's going to automatically display the matrix. So the purpose of the semicolon is just to suppress the output, suppress the command window output. So if I sort of add the semicolon back, if I click on it again, it's just going to display the script one, the name of the script I just run, but without displaying the content of A. Right. But now let's go back to my home directory. You can go back one level by using the dot slash. And now you are going back one level. It's how you can actually navigate through your file system by using a CD. CD means change directory. Now suppose if I click on the run button. Let's see what's going to happen. It's going to give you this dialog box. Basically, it was telling you that script 1 is not found in the current working directory because it's stored on the temp. So it's asking you if you want to change to that temp directory. You have several choices. One is that you can change to that temp directory. If you change to that temp directory, then script1.m is in the present working directory, and the present working directory is automatically searched by Matlab, so Matlab is going to be able to find that script and execute it. Right. Add to path means that you want to add the home PoChain temp, this directory, to your search path, to the Matlab search path. So every time Matlab is going to, if you type some command in the command window, Matlab is going to look through all those different folders, directories, path, and look for those the command name that I have just typed. Cancel help. So here I'm going to do change folder. So it's going to execute the script 1. Now suppose I don't want to sort of assign a particular matrix in my script. I want to load a particular text file. So what I can do is that I can convert all those numbers into like a text file. So what I'm going to do is that I'm going to save it. I'm going to save as. I'm going to use the save as. And I'm going to save it as a text file instead of Matlab code. I'm going to choose all file, and then I'm going to say a.txt. Save. Now you can sort of see the name of the file has been changed to a.txt. And inside of this a.txt, I'm going to change it to some kind of a text format. So it's basically a space delimited columns. I have like 1, 2, 3, 4, 4 columns, and then I can just save it. If I do ls a.txt here, I should be able to see this particular text file. Now if I want to load this particular variable, this particular matrix, into some kind of variable name, suppose I call it b, I can use the load function. Load followed by the name of the text file that I just sort of typed up, and then the name of the text file has to be inside of the single quotes. Now you have a B, and you can sort of see here you have both A and B, and you can subtract them. A subtract B, it's all zeros because A and B are sort of identical. They are just having different names. So if you have a text file that's sort of formatted like that kind of thing, you can always use the load command or load function to load that entire file into a matrix inside of Matlab. And the load function can be quite useful. If you sort of want to sort of know the details about this load function, you can type help load. Then it's gonna show you how to use the load function. And so if you actually look at the load function, you can also look at the save function. So this is a hyperlink, so you can click on it. Then it's gonna display save. How you can actually save a matrix or save your workspace to a particular file. And it's got different kind of formats, either binary format or text format, that kind of thing. And it's actually giving you some examples, for example, giving you some examples about how to use the save command. So let's look at some of the commands that allows you to generate special matrices. So if you would like to generate a matrix that's filled with zeros, you can use the zeros command. So big Z equals to zeros. How many rows do you want? Suppose I want 2 rows, 4 columns. Then I can just type 2, 4. So zeros is a function. And it takes 2 inputs, 2 and 4. It's just a row number and a column number. And then it's going to give you a 2 row, 4 column matrix that's filled with zeros. And then you can use ones. Suppose you want a matrix that's filled with ones. So 2, 3, 2 rows, 3 columns. That's a matrix with 2 rows, 3 columns and filled with 1. And suppose you would like to have a diagonal matrix. Suppose I want a G equals to a diagonal matrix. Suppose how to generate a diagonal matrix? You use the command called I, and then 3, 3, for example. You want 3 rows, 3 columns. In this case, you can actually neglect one of them because you are going to want a square matrix, 3 rows, 3 columns, right? And it doesn't have to be a square matrix. Suppose you want 3 rows but 4 columns. Then it's going to give you this kind of matrix. So it's not, so this is because it's not a square matrix. So it's you cannot really say this is diagonal. There's no diagonal here, but you can sort of see there's a 0. That's the kind of, but you can sort of still see that if you get rid of the last column, it's still a diagonal matrix. It's an identity matrix. So these 3 commands allows you to generate some sort of elementary matrix. And then suppose you would like to have a matrix that's filled with 5, for example. Then what you can do is there are 2 ways for you to do that, of course. You can do Z equals to ZROS, there's 2 rows, 4 columns, plus 5. Then it's going to give you a matrix that's 2 rows, 4 columns, filled with 5, for example. And of course, you can also do that using ones, but using a multiplication. It's giving you exactly the same effect. So, talking about the diagonals, we can sort of look at another command that's called diag. So, suppose I want to generate a random matrix. So A equals to rand. I'm gonna do a 5 by 5 matrix. It's a 5 by 5 matrix filled with random numbers between 0 and 1. So you can sort of see that. Suppose I want to extract the diagonal of this random matrix. I can do diaga, and then I can store it into another vector that's called a small d, suppose. and then the diagonal is going to be extracted and then stored in the vector D. And here it's actually displaying the numbers, right? And suppose I would like to retrieve the numbers that's off diagonal. Suppose I'm going to define another variable, but I'm going to give a second input that's D1, that's 1. So you can sort of see what's actually happening. It's actually taking out these 4 numbers. So it's not exactly diagonal, but it's sort of shifted by 1 off diagonal. Of course, you can use -1 to get the bottom half, not bottom half, but the lower 4 numbers that's off diagonal. You can sort of see those. Am I right? I can't. 4A. That's the lower diagonal, right? Of course, you can do 2, right? That's gonna give you the 3 numbers that's offset by 2 off diagonal, or -2. Oh, -2, right? So suppose if you want to sort of construct a diagonal matrix using a specific vector. Suppose I want to use D to construct a diagonal matrix with the elements inside of D on the diagonal. How I'm going to do that, right? So if I do DIAGD, you can sort of see it's going to give me a diagonal matrix, but the input is not a matrix, it's a vector. You can see that, right? So you can use diag in 2 different ways: for extracting the diagonal out of a matrix, and for constructing a matrix using the input vector, the elements in the input vector as diagonal. So if you do a help DIAG, then it's going to show you exactly how to use the diagonal, the DIAG function to construct special kind of matrices. So you can also try to sort of join smaller matrices into a bigger matrix. So suppose let's try to construct a small matrix that's do I still have my B matrix here. So if I look at my B matrix, that's my B matrix. Suppose I want to construct a bigger matrix. Let's call it big D. I want to use big D, and I want to construct big D matrix from the small B matrix. So I can do that. So I'm gonna construct this B, and then I'm gonna put the entire B matrix as a sub-block on the upper left corner. And then on the same row, I'm gonna do a B plus, say B plus 32. And then I'm gonna switch to a second row, second block row actually. It's not exactly a row. And then B plus 48, B plus 16. So you can sort of see here is actually from this element to this is actually so B subtract plus 32. That's going to be here. So the left half is actually B. The right half is actually B plus 32. And then it's going to switch to the second row, and then B plus 48, B plus 16. So the left half is going to be B plus 48. The right half is going to be B plus 16. So suppose that's one of the ways for constructing bigger matrix out of smaller matrix. Right? There's another way called repmat. Suppose I would like to repeat the matrix B. 3, 2, for example. So it's going to repeat the matrix B 3 times in the row, and then 2 times in the column. So you can sort of see where's my B matrix. So that's my B matrix, and then it's going to be repeated 3 times in the row. So this is the first time in the row. That's the second time in the row. That's the third time in the row, and then 2 times in the column. So from this column to this column, that's the first time, first repetition on the column, and then from this column to this column, that's the second time of repetition. So if you want to just repeat a small matrix by a number of times, you can use repmat. Again, if you want to sort of find out the details about repmat, type help repmat, and it's going to tell you how to use repmat. Some slightly more complicated examples, for example, Kronecker tensor product, that kind of thing. It's called a Kron, K-R-O-N. If you want to do a tensor product of matrices, you can use the Kron. If you know what tensor product actually is, right? And the Kron is a command for you to do a tensor product of matrices, and you can do help Kron. It's gonna tell you how to do a tensor product if it is useful for your application.